Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we will study about how to convert any hexadecimal number into equivalent decimal number. We start with the base, or we call it radix, because we are converting hexadecimal into decimal. So we should know what exactly we mean by decimal number system and what is hexadecimal number system. So in case of decimal, we know that we always take a base of 10. While in case of hexadecimal number system, the base is 16. While converting hexadecimal to decimal, we should know that the position is very important and it is known as a weighted position. We start our number from LSB to MSB, that is the least significant bit, and we travel from right to left. Number goes on increasing. The value of number goes on increasing. So it is depends on the position. Position is very important and it is known as a weighted position. We start with a decimal number system to understand, and then we go for hexadecimal number system. We start with the right extreme point, and that is known as a zeroth position, and we have base of decimal, that is 10, and we take power. Base remain constant and that is 10, but power change. So accordingly the value based on the position will change. So 10 raised to 0, then first position, then we have value, that is 10 raised to 1, then second position we have 10 and power 2. Same way we have third position and we have 10 raised to power 3, and then as we go on left side more, then the value of number goes on increasing. Same weighted position rule apply for hexadecimal also. So in any hexadecimal integer value, we start with the zeroth position, we take base 16 and we start with power 0. Then for the first position we have again base remain constant, that is 16, power change, and accordingly the value of the, as per the position, the value of the number change. For second position we have 16 raised to power 2. For third position we have 16 raised to power 3. So similar way, when we travel from right to left, the value based on the position will increase. This is known as a weighted position. So we know that 16 raised to 0, that is equal to 1. We have power 0 for any base, then number comes to 1. Then we have 16 raised to power 1, that is 16. 16 raised to power 2, that is 256. 16 raised to power 3, that is 4096. 16 raised to power 4, that is 65,536. We need a calculator while converting hexadecimal number into decimal number system. We have 16 raised to minus 1. When we say minus 1, then we have to take it 1 divided by 16. So it comes to 0.0625. Then 16 raised to minus 2, that is 1 divided by 16 power 2. So 1 divided by 16 multiplied by 16. So it comes to 0.00390,625. But in case of hexadecimal to decimal conversion, we go for maximum 2 point after a fraction value, 2 digit. So now let us start actual conversion from hexadecimal to decimal number system, and then the calculation or conversion will be very much clear to you. We take one hexadecimal number, that is 223, that is one of the hexadecimal number, and that is integer value. So we convert 2 to 3, right? So we first write the position. Position is very important, and position, weighted position, based on the weighted position we have different values, right? So we start with the 0th position, so it is 16 raised to power 0. We have first position, then we have 16 power 1, then we have second position, we have 16 raised to power 2. So base we always take as a 16, and power goes on increasing when we go from right to left. Now we have to multiply actual digit with its weighted position or value, right? And then we have to, at the end, we have to do summation of all the values. So 3 and multiplied by 16 raised to power 0, 2 multiplied by 16 raised to power 1, and again 2 multiplied by 16 raised to power 2. And then we have to do summation. Now if we do multiplication and simplification, then we have 2 multiplied by 16 raised to power 2, then it comes to 512, because 16 raised to power 2, that is 256, and if we multiply with 2, then it comes to 512. Then we have 16 raised to power 1, that is 16, and multiplied by 2, that comes to 32, and 16 raised to power 0, that is 1, and multiplied by 3, that is 3. So if we do the addition of 512 plus 32 plus 3, then the answer is 547. So 547, that is equivalent decimal number. We had 223, that was a hexadecimal number, and equivalent value of hexadecimal we have 547. So we can write 223, that was a hexadecimal number system, and equivalent decimal number system. So this way we can do the conversion from hexadecimal to decimal. Let us take one more example, and then the conversion will be very easy for you. Let us take B9C0. This is hexadecimal number, and we should know that what exactly we mean by B and what we mean by C. So B is 11, C is 12 in hexadecimal number system. We have A, B, C, D, E, F. So we write B9C0. First we write the position. Position is very important, as I discussed earlier, that first 0th position we start from the right extreme point. So 16 raised to power 0, first position, second position, and third position. So up to 16 raised to power 3 we go for our third position. Now we multiply actual value with its position, weighted position. So 0 multiplied by 16 raised to 0. C, that is, as I said, we have to consider 12. Equivalent decimal value we have to consider. So in hexadecimal, C, that is equal to the 12. 12 multiplied by 16 raised to power 1. 9 multiplied by 16 raised to power 2. And B, that is 11. So 11 multiplied by 16 raised to power 3. We have to do the summation of the entire number, and if we multiply and simplify, then it is coming to 45056 plus 2304 plus 192 and plus 0, because we are multiplying with 0, so it will come to 0. And if we do the addition, then it will come to 47552. That is equivalent decimal number. So B9C0 hexadecimal number we have converted into equivalent decimal number system. Now let us take one mixed number. So you should know that in case of integer how to convert, or what is the position value, and in case of fractional value what exactly the conversion process is. See, now for integer value, we know that we start with the 0th position. So from the radix point or from the fractional point, for the integer value we travel from right to left. So the LSB, that is f, we write f as a 0th position, and we go on increasing when we travel from right to left, right? So for and after point, for the fractional value, we start with -1, right? So 16 raised to -1, then 16 raised to 0, and then 16 raised to 1. So this should be clear that we start with 0 for the least significant bit of the integer value, and we start with -1, power -1, and then as we travel from left to right, the power goes on as -2, -3, and so on. So now we have a multiplication, a multiplied by 16 raised to -1, then f is 15, a that was 10, then we have to do the addition, then it comes to 16, then it comes 16 raised to 0, that is 16, 1 and 1 multiplied by 15, that is 15, and a is equal to 10, and we have 1 divided by 16, so ultimately it comes to 0.625, and if we do the addition, then the value comes to 31.625, right? So this is the equivalent decimal value. So 15.a hexadecimal number can be converted into equivalent decimal number, and that is 31.625. So this way we can convert our hexadecimal number, any hexadecimal number, into equivalent decimal number system. Only the important point is its weighted position. Position matters a lot. So thank you for watching my video. Keep watching. Thank you very much.